Hello students, this is Rajeev Katare, Assistant Professor, School of IT, AURO University, welcomes you all on behalf of School of IT and AURO University. Today, let me introduce you something about vision and mission of AURO University and School of IT. So, first of all, vision. To be a premier university of integral and transformational learning for future leaders. And mission for School of Information Technology is the effective contribution from the School of IT is to inspire and nurture fresh minds to initiate with innovative ideas, dreams to transform into reality as trained IT high-tech professional leaders by placing such transformed IT leaders with modern advanced technical skill set throughout the world through capitalizing on enriched modern resources, facilities within world-class premium or university as learners to leaders. Currently, the following professional courses were offered, which you are seeing on the screen. So, number one here it is BSc IT 3-year program, then MSc IT integrated 5-year course that include 3-year BSc IT and 2-year MSc IT, and then MSc IT 2-year program separately, and MSc AI 2-year program, then PG Diploma AI 1-year program, and short-term courses on Python for financial analysis, and many more other short-term courses are yet to come. Objectives of School of Information Technology or University. So we have various objectives. Number one is conceptions to create highly IT technical professionals to deliver their best with exceptional performance in the highly competitive technical world. Strength in continuation with multiple collaborations with IT industries around the world and its growth. School of IT keeps on building, started from single UG or BSc IT to multiple UG and PG program, many to start. Organizes multiple conferences, seminars, workshops, training programs conducted by the senior IT professionals from reputed IT industries, MNCs, and eminent academicians. I think you all well aware about this particular importance of this particular concepts, the organization of various activities like seminar, workshop, training programs, etc. Opportunities organizes live projects implementing in demand advanced technologies, achieve standards for internship and placements, especially for master's program. Then enrich facilities, resources such as our books, journals, magazines in library, latest configuration, hardware and software in IT labs, technically updated faculty members which create overall conducive high-tech environment. Priority. The main priority focus is on to students of School of IT as they are the premium brand ambassadors of our School of IT and AURO University. Teamwork. Students of School of IT being placed in IT, MNCs, industries in becoming a great help as effective team members to School of IT of AURO University for collaborations and organizing workshops and seminars to train and develop students for internship and placements. Model. This teamwork role by the students, alumni of School of IT creates cyclic model for which School of IT will always keep on making efforts to develop such ideal model. Then openness. The brand image of School of IT is always open to welcome any relevant technical ideas which is helpful in upliftment of the technical knowledge through practical practices for the students. So uh, here we have discussed, I just tell you about the vision and missions of AURO University as well as the School of IT. Now I am proceeding towards today's lecture, and here today I am going to discuss about something introduction to machine learning. All right, so feeling quite excited. Here it is. Machine learning is the idea that there are generic algorithm that can tell you something. Remember, it's a technology designed to build intelligent systems. These systems also have the ability to learn from past experience or analyze historical data. So any machine any machine will be able to learn with the help of past experience in terms of human being, but in terms of computer system, it's a historical data. The more historical data we have in case of machine learning, the more knowledge that particular machine learns. So it provides a result according to its experience, right? So this is about something machine learning. Then traditional business intelligence. I'm talking about the history of machine learning. Before the era of machine learning. So previously we used to have the traditional business intelligence in which we used to have structured data in databases, human defined queries or rules, set of rules, and then focused on analysis of past data only. Correct? But in case of machine learning, we have to train machine learning model on historical data. I just explained 1 minute back because training of machine learning model is on historical data and then deploy the model to take predictions on new data, right? Regularly retrain the model. See, once we have given some historical data to our machine, so it has some knowledge. Then after that, we thought that okay, we wanted to train more. Then that is known as retrain. So retraining means we have to add again the new data. Focus on making predictions about future data, right? So based on the historical data, we can predict the overall what will be the future data will be the outcome of that, right? So, for example, I'll tell you a very simple example so that you can understand it quite easily. Suppose we have stock market data, right? And suppose we have picked 1 year stock market data, and based on that, if we develop some machine learning model and apply that 1 year historical data into our machine learning, and what we will be able to see, we can predict almost up to quite a certain level that what will be the rate of particular stock in coming future days. Okay, so there is a difference between these things. Okay, now let me take you to the some small diagram. Look at here, the traditional rule-based approach versus machine learning approach, right? In case of rule-based approach, we have if then else condition type of things there. If condition is true, then particular code will be executed. Otherwise, if condition is false, then other code will be executed. It's a normal process, right? Now, in case of machine learning, we have training data. Okay, with help of training data, we create some model of the machine learning. Now, once we created that model, then in that model, if we input some new data, then it will predict the future data as well. Correct? So this is the way how we deal with how we create and use the machine learning things. All right. Now come to the next portion, that is our types of machine learning. So I'll tell you, basically machine learnings are of three types majorly, right? Further, it can be divided into subdivisions, but on a larger scale, it has been divided into three parts. One is supervised learning, second is unsupervised learning, and the third one is reinforcement learning. See, the difference between these three, if you wanted to differentiate or if you want to understand these three kinds of machine learning, three types of machine learning, then simple. In case of supervised learning, it's basically on task-driven things. In case of unsupervised, it is fully data-driven, and reinforcement is totally different among the three, right? So the difference between these is quite clear. So in case of reinforcement, it is an algorithm, it is kind of learning, it is a kind of technique in which it learns to react to environment, right? So based on past experience, it immediately reacts to that particular environment. So this is the way how we can differentiate between these things, right? Okay, I'll take you one nice figure so that you can understand what actually supervised learning is, right? So just look at that. Here we have, see this diagram, here we have small dots of three different colors, that is red, green and blue. So this is the raw data, okay? See the outcome here, output is here. It is all these raw data or these three colors will be separated clearly in case of output, right? Red is separate, green is separate and blue at last is separate. So this is our output and input things, right? And in between we have some model. So how it actually works, how it is like, it looks like, see here, we have training data set, supervisor and desired output. Actually training data set is inputted by the supervisor things and also desired output inputted by the supervisor. Now that input goes to the algorithm and based on that it do some processing. Processing is a part of that algorithm and produces the proper output. So remember here in case of supervised learning, what I just said, supervised learning, some input data, some algorithm and processing, and then it produces the desired result and output, predicted data or output. Okay, so this is the thing how it will works. See, if I wanted to explain you in more elaborated way, then I can just tell you that supervised learning is just like human learning from past experiences. Okay, so for example, just understand this: a computer doesn't have any experiences, right? A computer actually a computer system learns from data, right? Which represents some past experiences of an application domain. I mean, for a particular application domain, like it may be financial, it may be medical, it may be health sector, it may be your banking sector, any. You may pick any field, and there you will be able to apply this technique. So here, overall point is experiences. Like human being has experiences on particular each and every or particular domain. Similarly, a computer does not have any experiences, right? So how do computer learn? How computer is going to learn the concepts? So that thing is possible with the help of past data, or that is known as in terms of computer past experiences, right? If you compare with the human experiences, right? So next is supervised learning. I'll tell you something more about this. How actually we can create an algorithm or how we develop the model or how it actually works. So supervised learning is the machine learning task of determining a function from labeled data. See here I'm coining one word that is known as labeled data. Okay, I mean data that has certain label, right? So it actually works on those things. For example, let's take one simple example in case of health sector. Suppose uh, a person has certain disease, right? So we have to find out, we have to figure it out, different symptoms that particular person has. Now that particular systems are known as labeled data. Now that particular labeled data will be matched with the past history data. So based on that, it will works. It will figure it out whether that particular person is having particular. It will diagnose whether that particular person is having a particular disease or not. It will confirm it. Like for example, I'll take you a very good example of in current scenario. It is corona, right? So what we have to do here? Suppose a person having some cough and cold, some temperature is there, and also we have one more label data, that is X-ray of his whole chest area. Now, based on the past record of all the corona patients, we have to match with those things with the current things. So based on that, we will be identify easily that whether this particular person is having corona or not. Okay, so this is the way how we can deal with the thing. All right. Next, I'll explain you more in elaborative way by the particular diagram. See this? How supervised machine learning works. So we have divided into here two steps, right? Number one is step one is provide the machine learning algorithm categorized or labeled input and output data from to learn. And then see here first in this case of step one, we have labels like cat, and we have three different smaller photographs or set of these different kinds of cats here, right? And we here by side of that we have one machine, that a diagram that represents actually machine, right? In here we are feeding the input of that particular cat, known as labeled as a cat, and then that labeled cat will be inserted into the machine or a set of algorithm or model. Now see, till here it is clear. Now come to the step 2. Feed the machine new unlabeled information to see if it tags new data appropriately. If not, continue refining the algorithm. See here, out of these three, see here, we have stacks of all these three itself, right? One or more first figure, then one or more of second and third and so on. So all these three will be inserted here. Similarly, in the case of step 2, if it is cats, then it will be matched with the provided tags, right? Whether it is cat or not. If not cat, then it will be separated here. Or if it is cat, it will be separated on another direction. So types of problems to which it is suited, where we can apply the supervised machine learning. So that's what we have two types of things here. One is classification and this is regression. Okay, so that is, so in case of classification, first, here classification means sorting items into categories, right? Segregate the things. Similarly, in case of regression, these are actually I'm discussing about type of machine learning. So regression means identifying real values. Uh, in a short way, if you wanted to understand, then or you can understand, it's like we are categorizing the things in case of classification, and we are in case of regression, we are using the numerical data or numerical value directly. That may be fraction or the whole number, right? Like rupees, dollars, weights, right? Distances, meters, all this comes under regression, the numerical value. Okay. So, okay, let's take one clear-cut example. Suppose we have a hospital and there we wanted to allocate the bed, right? Let's take an emergency room in a hospital that measures around 17 different variables. 17 variables that may include, n number of variables that may include blood pressure, age, or something like that of newly admitted patients, right? A decision is needed what? Whether to put a new patient in an ICU or intensive care unit or not. Okay, so we have to take a decision based on all these labeled data or different variables, right? Why we want to take this in? Because due to high cost of ICU, those patients who may survive less than a month are given high priority. Obviously, who are severe, they will be given high priority. So the problem actually, how we can clarify, how we can define the problem to protect high risk patient and discriminate them from low risk patient, right? So for that, it is very clear. I told you we have certain number of variables. Like in case of hospital bed location, we have blood pressure, age, etc., and as well as gender and so on. Similarly, let's take another example. A credit card company receives thousands of applications for new cards, right? Each application contains information about an applicant, like it may have age, it may have marital status, the annual salary of that particular person, then outstanding debts, credit rating, etc. These are the things. So, what is the problem? How we can define the problem? So, to decide whether an application should approved or to classify applications into two categories, right? Approved or not approved. So, based on that, we have to find it out. So we have two categories here, approved and not approved. Okay. So this is the thing. These are some few examples I'll just given you where we can apply our own uh, machine learning things. Another example, let's take in case of everybody has Gmail or any other mail. So if you wanted to learn a system so that he can that particular system can filter out our spam. For that, obviously, we have to train them. We have to use here some certain kind of machine learning model so that this proper filtering will be done. Okay. So, for example, suppose we were using Gmail, Outlook, Yahoo, something. So, learning algorithms are used for deciding which email is spam and which is not. Based on the previous data, like received mails, past historical data. I already am using this particular thing many times. Past historical data. So, what data here? Past spammed mails, right? System makes a prediction about an email as per whether it is a spam or not, right? So this is the way. These predictions may not be perfect, but they are accurate most of the times. Okay. Obviously, each and every machine learning model has its own limitations, has its own certain level of perfection. So based on that, it is. So this is something about our supervised machine learning model, a kind of machine learning model. Now, next, come to the unsupervised learning. I think you remember how the supervised learning model works, right? Now, look at the diagram for the unsupervised learning. See here, input raw data here. Again, the same thing is here, like in case of supervised. But see here, there is no supervisor. There is no past historical data as such. So just remember these things, right? Difference between this unsupervised. See, the term is here unsupervised. There is no supervision. Okay. So this is our interpretation. Okay. How we are going to interpret it and put it into the algorithm. Then some processing. See, algorithm and processing is a part of each and every machine learning algorithm. So that's why it is like that. Now, the whole thing is dependent on this algorithm and processing in case of either supervised or unsupervised or any other kind of machine learning. Now, after processing, it will produce, it will divide it, it will classify this particular chunks of input raw data of mix of colors into three separate kinds of colors like RGB, red, green, and blue. All right. So this is the diagram how this unsupervised learning actually works, right? Now, just look at that very good example. It's a very nice example so that you can understand, okay, how in the unsupervised learning can be applied over the image recognition. Okay, look at that. Here we have 4 by 4 image where we have 4 row and 4 columns of the images of puppies and muffins. Now, for the human being, it is quite easy to understand, okay, which particular image is a puppy or which particular image is a muffin. Though it's quite difficult to resemble, okay, for somebody, but because they are looks like almost same, but for the human being, it's quite simple to identify, okay, what particular images are of puppy and what are the of muffin. So this is just for I taken for example that how we can apply the things into the image recognition in case of unsupervised learning. All right. So this is something about I just told you. Now, if we compare between these two, like supervised or unsupervised learning, then how we can differentiate that? See, I'll give you more description about unsupervised learning, but I'm going to I'm going to give you more description about this unsupervised based on the supervised. So let's just compare a bit between these two. So in case of supervised, classification is seen there, right? We have just remembered their regression, classification, and all these things. Okay, but in case of unsupervised, that is termed as clustering. Remember the word clustering. So in case of supervised learning, we have classification and regression, but in case of unsupervised learning, we have clustering. And in case of supervised learning, we don't have any. Remember again, in case of supervised learning, we have supervisors or we have a kind of data which actually differentiate from unsupervised, and that data is our labeled data, because in unsupervised learning we don't have any labeled data. Then it's quite amazing that you would be amazed to know that then how it is possible to identify that. Obviously we are going to clustering it. Okay, let's take you all to the particular example of this. See the differentiation between these two. Supervised learning, where we have applied the classification algorithm, and here it is unsupervised learning. We don't have any label data here. Here we have label data like duck, duck, not duck, not duck, right? We have two labels here. Now, look at this particular diagram very carefully. Here we have supervised learning model, a machine which we have applied here for the predictive model. The predictive model is ready to identify any particular new input of data. Now, as soon as we input the data as an image, it will to the predictive model, it will produce as a duck as the output, right? But in case of unsupervised learning, we did not label any of these images. Remember this, we did not label any of these images. So the whole image will be categorized or segregated or clustered into separate based on their features itself, right? It will identify, for example, this particular rabbit is separate and these three ducks are separate and rest one is separate, and so on. So this is the way how the supervised learning and machine unsupervised learning works here. Okay, now I think it's quite clear to all of you. So here we have learned things that is known as classification, and we have learned clustering. I'll give you one very interesting example in case of unsupervised learning. That is face recognition is Facebook, right? Have you seen that when you upload a photo on Facebook, it can recognize a person in that photo, right? Immediately it will, there is some square comes up. So it means that it is identifying that and suggest you for the mutual friends, right? ML is used for these predictions, right? Machine learning is actually used for this. It uses data like your friend list, photos available, etc., and it makes predictions based on that, right? Another example I'll take for you. In marketing, we have segment customers according to their similarities to do targeted marketing, right? If you wanted to target a particular gender, you want to target a particular age group or something like that. So segmented, targeted marketing. All right. So till now here we have reached from where machine learning. We have two types. We have just gone through with, that is supervised, and second one is unsupervised. Now supervised again has classification and regression, and then unsupervised has clustering. Okay. So till now we have seen these two things and their types. Now next comes the reinforcement learning. It's entirely different than our past two models. So, okay, let's understand what actually reinforcement learning is. So, reinforcement learning is a field in artificial intelligence, machine learning, or a kind of machine learning which is inspired by behaviorist psychology. Okay, uh, I'll take you a very simple example of children. Okay, let me give you one very good example of a particular small child or boy, where a boy has seen his parents to watch the television with the remote, right? Now imagine, and he has already seen that there is some environment, that is television, and the baby itself known as agent here, and the curious baby will take certain actions like hitting the remote action. I mean, he wanted to switch on the television with the remote, as he has already seen uh, that his parent was doing previously. So based on their action, he actually watched. He used to hit the remote first, but TV is not working, right? TV is not responding. Then the baby dislike it, right? Receiving a negative rewards. Here I am talking about reward, okay? Because he is getting negative things because he used the remote by hitting or something motion here and there, but he just found that TV is not working. So this is our negative rewards. and will take less action towards that direction. I mean, next time he won't repeat the same thing. Okay. So next time again he will pick the remote and he'll again do another task, refine itself, right? I mean, you can say updating the policy. Now again he will watch, parent, and then again finally keep on refining. Finally, at last he will switch on the TV. Now that is becomes positive reward for that baby. Okay, so this is some sort of reinforcement learning. Let's view what a particular example of that in case of dog training. So before conditioning, we have food. There is no stimulus. This is actually experiment performed by some biologist related with bell and dog and food. So just look at that. Here we have unconditioned stimulus, that is food, and dog having saliva, right? Now next, in case of that, the particular scientist actually ringing the bell, dog has no response. He has no salivation. Okay, so no conditioned response. That's why it is the neutral stimulus. Means just bell, because the dog know that with the help of bell sound, he's not going to help it out, right? Then again, what that scientist do? As soon as he put the food in front of dog, simultaneously he put the bell, ring the bell as well. Now the bell and food becomes new stimulus for that dog. So again, here the factor is food itself, but with the food they have included bell as well. Now whenever there is a bell, the dog start salivation. Okay, so this is how it will works. Okay, so here previously they have attached bell with the food, and based on that it will. Next, you can take consider the case of robotic navigation in case of reinforcement learning. So a robot can make very precise movements to perform a task, yet the robot has to learn to perform these movements through repeated tests, right? Obviously, I mean, certain things he has to repeat. Then only it will reach to that particular level of efficiency. It applies the knowledge gained from this to improve its efficiency. This is the basis of reinforced learning. Okay. So in robotic navigation, another similar system means similar to that, such as you can take latest example nowadays running as a self-driving car, right? Sensor doors. The output is not restricted to a single action. It may contain a multiple sequence of actions, right? Okay, from self-improving cars, which tend to perform reinforcement learning with safety and precision, this technology can also be used for robots as well. Yeah, of course, without using manual programming, and can figure out the configuration required for the apparatus in a data center. Okay, and nowadays a lot of companies working there on the this reinforcement learning like Mobileye, OpenAI, Google, Uber, DeepMind, and so on, right? Okay, so this is something I just told you about the three different kinds of learning: supervised, unsupervised, as well as our third one is reinforcement learning. Okay, reinforcement learning based on feedback, entirely different from other two, the previous two. Next, come to the point, different approaches of machine learning. So what are the different approaches? So as we have just seen, there are three major kinds of machine learning, and under that we have different subdivisions of that. So decision tree learning is a kind of machine learning, support vector machines, association rule learning, artificial neural network, inducive logic programming, reinforcement learning, yeah, just I described, clustering, again unsupervised, similarity and metric learning, Bayesian networks, representation, and so on. I mean, there are a number of different kinds of learning which can be implemented. Okay, so this is how it will work, and the kind of machine learning which we have just seen here. Okay, now one major point we have to decide, we have to understand when to use machine learning. Okay, on what kind of task we can apply our machine learning model, or we can create our machine learning, right? So first of all, we have to ask this particular question, right? What is that question? Do you need machine learning? And for that, obviously, we have again some questions like, do you need to automate the task, right? Where we wanted to apply the machine learning model. And high volume tasks with complex rules and unstructured data are good candidates. I mean, we have very high volume of tasks, right? And complex rules, conditions, things, and unstructured data. We don't have any structured data. So these are all really good candidates to apply on the machine learning, right? For example, suppose we have some sentiment analysis for any particular domain, any particular field. For example, let's take one problem is formulation. Can you formulate your problem clearly? Number one. Then, what do you want to predict given which input? Suppose some input has been given to you, then what do you want to predict? So you must be clear based on that. So what is the pattern has been given? Given X and predict Y, right? X is given and we have to predict the Y. Then in that case, what should be the input? What would be the output, right? So I'm talking about sentiment analysis. Suppose a particular customer has given a review of a particular product, right? Now predict its sentiment, right? So here input becomes customer review text, output becomes positive, negative, or neutral provided by the customer itself. Okay. Now next point is collecting data. Do you have sufficient examples for that? That is, machine learning always requires data, or generally the more data, the better things are there. Because suppose we have loaded a huge amount of data, is that huge amount of data are really going to be helpful for us? So these are certain things, right, which we have to keep in mind. Similarly, in case of natural language processing, also, if you wanted to apply the machine learning things in case of NLP, that is natural language processing, then we can apply there like recruitment of a particular candidate. So how it is possible? Understand this. A particular person has applied for a particular post, then he has written the whole detail into the natural language and known as English, right? Mostly because candidates are applied in English language, that's why I'm taking this example. Now, with the help of natural language processing, we have developed some machine learning model. Now, that machine learning model actually matches with the past recruited candidates' data of particular of all the CVs, and that will be matched with the inputted information of that particular user which he has just applied. Now, after comparing, the machine learning model can identify whether this particular person is going to be recruited or not. So this is a good example. Similarly, in case of computer vision, we can also apply this, right? Suppose we have went to certain malls and given picture of retail shelf where a lot of products of related with retails were putting there. So detect all the products in the picture and compare with planned layout, right? So do we need here again the same thing, right? Similarly, suppose we have fashion apparel color analysis. So again here we have to apply the computer vision things in case with machine learning. Fashion apparel color analysis means uh, obviously we have to first look out for the social media or other platform to detect the trends currently, what kind of trends are going on, and once we pick the pictures of that, then we can identify further, okay, and apply machine learning whether this particular trend is good or not. So based on these things we can, right, apply. Now at last, I'll give you some very small cheat sheets things here. It's very good and nice cheat sheets to summarize the all things at one place. That is how to start, how to identify whether we are going to use the machine learning and how we are going to apply the machine learning. So look at here. This is the start state. At the very first, it is written there. Then there is arrow. Do you need automation? these all things I already discussed here previously. So question is, do you need automation? If yes, can you write the rules? If no, then manual task. They have to perform the task manually, right? As we don't need to automate the things. Then if it is yes, can you write the rules? Rules means if else then condition things. Then if yes, then we have to go through the rule based. Uh, we have to create the rule based logic, and based on that we have to implement our task. Right? If we don't convert the particular problem into the rule based things, then can you, next question we have to ask, can you formulate your problem clearly? If yes, then do you have data? If no, then refine your problem. Why? Because see, if we are unable to convert it to the rule, if we are interested to automate the whole process, right, then certainly we have some data, because without data, historical data especially, we can't do anything. So refine your problem. Okay. Now come to the next stage. Do you have data? Yes. Then do you have a regular plan? No. If you have no data, then collect data. This is the thing, right? So we have to collect the data, historical data that I just said. Now, if you have a regular plan based on particular certain domain and task, then enhance, if we have, then again we have to ask, do you have meaningful features? If the question was yes. If no, then enhance data, look for different data sources. Okay. And if in the question, do you have meaningful features? Answer is no. Again, the enhanced data and look for different data sources. If yes, then can you measure success? Okay. I mean, whatsoever outcome going to become here, can we measure that? If yes, then apply the machine learning. Then apply the particular task into the machine learning. If no, then refine your problem again. Okay, so this is the whole things which I wanted to tell you about this machine learning things and our types of machine learning and